This is Unit 4, Lesson 3. And today we are going to be simplifying expressions containing complex numbers. Simplifying expressions containing complex numbers. Okay, so our goal for all of these problems, because all of the problems that we're going to be taking a look at are going to be a fraction. And every single one of these fractions is going to have an I in the bottom in our denominator. So I'm going to say an expression can't have an I in the denominator. It's not simplified if there's an I in the denominator. So our goal here is we need to get rid of those I's that are in the denominator. Let's take a look at example 1. The directions will say simplify. Let's lift that up a little bit. There we go. So here's our problem. I've got 5 over 3i. I've got to get rid of that I in the denominator. So our strategy is I've got to get rid of those i's, so I'd be trying to make those i's squared. So I can turn that I squared into a negative 1. That should really be your strategy. So in order to make this an I squared, I would have to multiply it by I. Well, whatever I do in the bottom, I've got to do up in the top. I've got to make this equivalent. So when I multiply up in the top, I'm getting 5i over, so 5 times, well, remember with fractions you just multiply across. 5 times I is 5i, 3i times I is 3i squared. Okay, this I is fine up here. I've got to change this I squared to a negative 1. So I've got 5i over negative 3. Now, when you're leaving first of all, I'm checking to make sure the i's are going in the denominator, which they are. I don't have any I squared. All right, so I'm checking for 2 things. My final answer should not have an I in the denominator, and I shouldn't have any I squared anywhere in my answer, or I cubed, or a higher exponent. Now, this negative, you really should never leave an answer with a negative in the denominator. So what I'm going to do is I'm going to move that up. I can do that. I'm going to bring that negative up. So it's really negative 5i over 3. We're going to bring that negative up. So I'm not leaving a negative in my answer, in the denominator. Number 2. I've got 6 plus I over negative 7i. So 6 plus I over negative 7i. All right, we're going to follow the same procedure as we did in example number 1. I'm going to multiply by I over I. That first step doesn't change. Now here's the only thing. When you're multiplying, I try to get into the habit of telling my students, whenever you see a plus or a minus, put parentheses around it. If you don't, it's going to throw off the rest of your problem. You actually have to put them there. Because I'm going to multiply this times this, that means you're actually distributing that I. So this becomes 6i plus I squared over negative 7i times I is negative 7i squared. All right, so I'm going to stop here. I've got a bunch of i's going on. Let's see what we can do. I see some I squared. Let's take those and put some negative 1s in. So I'm putting a negative 1 in there for that I squared, and then negative 7 times negative 1. So I'm going to rewrite this as, I can clean this up a little bit. You can leave it as plus a negative 1, but it's the same thing as minus 1. Negative 7 times a negative 1 is a positive 7. Next problem. Now these last two problems are going to be a little bit more challenging. So for number 3, I actually have an expression in the bottom. I know it's an expression because there's an addition sign. If I have an addition or subtraction sign, that's an expression. So it's done a little bit, it's done differently than numbers 1 and 2. I can't just multiply by I. Here I multiplied by I over I. If I do that here, I'm going to end up with I squared plus 3I. I'm still going to end up with an I in the denominator, and I can't. So here's what we do. I put parentheses around that, and I multiply by the conjugate. Remember, the conjugate is the same exact expression, different sign. So this becomes I minus 3. And whatever I do in the bottom, I've got to do in the top. So let's distribute. I got to distribute here. I've got 4I minus 12 over. Now I've got conjugates in the denominator, so I'm going to do first and lasts. So I times I is I squared. 3 times negative 3, negative 9. All right, so let's see, this I is fine. Let's change that I squared. So I've got 4I minus 12 over, I'm going to put in that negative 1 for I. So I'm left with 4I minus 12 over negative 10. So I've got a couple of issues here with my answer. One, I've got a negative in the bottom. So I'm going to bring that negative up, and I'm going to change all the signs. That's going to be my first step. I'm going to take this. That means all the signs change up in the top, in the numerator. So it becomes a negative 4I plus 12. Now, I'm looking to see, can I reduce? I probably should have asked that up here. I kind of knew we didn't, that's why I didn't ask it. But 4, 12, and 10 all have a common factor of 2. So I can actually take this and divide everything by 2. This gives us negative 2I plus 6 over 5. Negative 4 divided by 2 is negative 2. 12 divided by 2 is 6. 10 divided by 2 is 5. Okay, let's do one more. Let's do 3I. Actually, let's change that. Let's do 3I over 2 minus 4I. So 3I over 2 minus 4I. So again, I've got an expression in the denominator. So in order for me to get rid of that expression that has an I in it, I need to multiply by the conjugate. So I'm going to put this in parentheses. I'm going to multiply by 2 plus 4I. Let's distribute up top. I've got 6I plus 12I squared over, I'm going to do first and last. So 2 times 2 is 4. Negative 4 times 4 is negative 16, and then I've got I squared. Now you can't just cancel, cancel, cancel. You can't reduce that way. I have to actually change those I squares to negative 1s. I can't do cancel, cancel. You can't do that. Not when there's an addition and subtraction sign. I've got plus 12 times negative 1. And then I'm substituting in a negative 1 in the bottom. So that's where those negative 1s come from. I've got 6I minus 12, 4 plus 16, which gives us 6i minus 12 over 20. Okay, is there a negative in the bottom? That's always my first question in the denominator. No, I don't need to move anything up. But 6, 12, and 20 all share a common factor of 2. Now, in order to reduce, all three numbers have to have a common factor. If they don't, you can't reduce it. Divide by 2, I'm getting 3i minus 6 over 10. 3i minus 6 over 10. And that is Unit 4, Lesson 3.